The graph editor is the most advanced keyframe manipulator in Blender. To access the graph editor, you have a few options. In any workspace, you could go to the top left-hand corner of any panel and select Graph Editor from the drop-down. Alternatively, you can go to the Animation workspace and go to the Dope Sheet area. From there, you can hover over it and press Ctrl-Tab. This will toggle between the Dope Sheet and the Graph Editor. For non-hotkey users, you can go to View, Toggle Graph Editor, or Toggle Graph Dope Sheet to achieve the same thing. Compared to the Dope Sheet, the Graph Editor can do many of the same things, but also allows the user to view and edit the motion curves directly. Let me show you what I mean. Let's go ahead and make some keyframes for our object so we can see what this looks like. Just like our timeline video, let's once again animate a simple bouncing ball. To do this, simply subdivide your default cube by holding Ctrl and pressing 2 on the number row. Then turn on Auto Keyframe. We'll set a keyframe for a high pose on the first frame, go to frame 10, set a low pose where it's touching the grid, set a much lower high pose on frame 15, and do the same thing as frame 10 for frame 20 for our final low pose. You may have noticed by now that our keyframes in the graph editor are represented by orange handles along the curves we see displayed. Now, we also want to change the handle type for our extreme low poses on frame 20 and 10. This will once again give us that bouncing ball look. However, let's figure out how to do that in the graph editor real quick. Unlike the Dope Sheet and Timeline, there is no summary of keyframes where we can easily select all of the keyframes on a certain frame. So to achieve this same effect, let's simply find frame 10 and Alt left click any of the keyframes on frame 10. This will select all keyframes vertically on the same frame as the keyframe you selected. Now we can simply change the handle type by going to Key, Handle Type, and selecting Vector. Hotkey users can still press V. Now, as you can see, the handles have visually changed this time. Unlike the Dope Sheet and Timeline, the graph editor directly shows you what changing the handle type looks like in terms of the interpolation curves. Let's repeat this process for frame 20. Alt left click, press V, select Vector. We can then play our animation with spacebar again to confirm that we did it right. Now let's observe our graph editor a little more closely to see how similar and how different it is from the Dope Sheet. Before we move on, I want to say that in case your graph editor is too zoomed in or you can't see all of your frames, simply hover over the graph editor and press Home. You can also go to View, View All. The first thing we'll notice that's the same is the left-hand column. Just like the Dope Sheet, the keyframes have all been assigned to specific channels. You can expand and collapse channels by clicking the arrow or using the plus or minus keys on the number pad while hovering over the channels. However, you might notice that while the channels are listed, there are no distinct rows of keyframes to see which keyframes belong to which channels. Now, we already know that the keyframes are indicated by the orange handles you see spread out along the curves. And each curve belongs to a channel. Simply left-click any of the channels on the left to highlight the corresponding curve in the graph. To isolate a curve, you can left-click to select it, go to the channel menu, and click Hide Unselected Curves. For hotkey users, you can press Shift-H, as in hide. This will hide all other curves for you. To unhide all other curves, simply go back into the same channel menu and select Reveal Curves. For hotkey users, you can press Alt-H. Now, let's go ahead and isolate only the location curves, and try to manipulate our keyframes and curves using the graph editor. As you can see, each of the keyframes in each channel exists on their respective curves as these orange handles, which we can select and transform using the same selection and transformation options we typically have in Blender. I'm going to simply shift left-click a few of these keyframes and start using G, S, and R to transform them. As you can see, moving, rotating, and scaling keyframes are all possible in the graph editor, allowing for very versatile and intuitive transformation of the curves. But what if we select a single handle? Each handle by itself is technically made up of 3 selectable parts, the main body and the 2 handlebars. By default, the endpoints of each handlebar can be transformed as a way to rotate the entire handle and manipulate the length of the handles, which affect how the curve interpolates between keyframes. You can also select the body and use R or S to rotate or scale both handlebars simultaneously. However, handle transformation differs depending on what handle type we use. For example, the vector handle types we have at the extreme low poses of our ball can be edited individually on each side. It also cannot be rotated as vector handle types must point to the previous keyframe. Quick note, when you break an individual handlebar off of its default orientation, it will convert the keyframe handle type to free. Free is when both handles move independently from each other, and you can set it to free yourself manually. Feel free to experiment with other handle types. Another thing we talked about is the interpolation modes. Interpolation modes can also be very easily changed in the dope sheet and timeline, but we never talked about what they look like in the graph editor. Since the graph editor is comprised specifically of interpolated curves, the interpolation mode greatly affects how the interpolated curves look. Let's try a few by isolating the Z location curve and selecting all the keyframes by pressing A. We can then go into the key menu, go to interpolation mode, and select constant. As you can see, the constant interpolation mode removes all curve interpolation and simply repeats the previous keyframe's value until it encounters another keyframe. If this looks like a familiar pattern to you, it might be because you saw it in the interpolation mode menu for constant. As you can see, each of the interpolation modes has an icon that represents what the curves look like when in that mode. Feel free to test out these modes to better understand them. Bezier, however, is the default, and we'll be changing ours back to Bezier for now. Now that we've gotten basic curve manipulation out of the way, let's talk about more advanced curve manipulation options, specifically curve modifiers. Curve modifiers are similar to mesh modifiers in that they are extremely powerful, non-destructive functions that can help you alter and adjust your curves. There are a few curve modifiers, but to demonstrate this, I'm going to show you how to use the noise curve modifier. To add curve modifiers, simply open the right-hand side menu in the graph editor. You can do this by clicking the arrow icon on the right or pressing the N key. From this right-hand side menu, go to the Modifiers tab. Make sure you have the curve you want to modify selected. We'll go ahead and select our Z location curve by clicking on the Z location channel on the left-hand side. Then we can go into the Add Modifier drop-down menu and select Noise. For hotkey users, you can simply hover over the graph editor and press Ctrl-Shift-M and select Noise from that menu. Immediately, you can see how the noise modifier affects our curve, as the curve now has a noise pattern added all throughout it. If we play our animation back, we can see that a slight shaking effect has now been added on top of our original animation. Even if we set new keyframes or move them around, the shaking effect adjusts to the curve dynamically. Just like mesh modifiers, we can also adjust the modifier settings to change how the modifier affects our curve. Each modifier has different settings to play around with, so feel free to experiment. But these two options at the bottom are available for every single curve modifier. This is because they affect the on and off state of the modifier. If we expand the Restrict Frame Range option, we can see a start and end range that we can set. This will allow us to restrict the effect of the modifier to specific frames along our curve. Additionally, the in and out frames will allow us to fade the modifier influence in and out a certain number of frames. For example, if I set the fade in value to 10, the curve modifier will slowly fade in the influence of the effect over the course of 10 frames. Furthermore, you can also manually adjust or keyframe the influence slider just below that under Use Influence. Collapsing either of these options will also disable them. Now, some of you may remember that the icon for modifiers for meshes is a wrench icon in the Properties tab. Similarly, in the graph editor, wrench icons also represent curve modifiers, but the only time you see this icon is next to the channel names. That's because this wrench icon next to the channels in the graph editor is for toggling on and off curve modifiers for that specific curve for your convenience. Likewise, the checkbox disables the curve's values from affecting the object at all, and the lock icon prevents changes to be made on that curve. As a final note, several of the dope sheet and timeline features exist here as well. For example, you can still add markers in the graph editor and edit them, and you can also set your preview range in the same way. I hope this video gives you a fundamental understanding of the graph editor in Blender.